Okay. So now let's draw the other equation, which is the price supply equation. So which we said it was it was P is equal with 0.1 x squared plus x plus 40. So, I mean, again, this here is a quadratic, but of course this opens upwards. I mean, the y-intercept, it will be the c, which is 40. So let's say it's approximately here. And I mean, the vertex, the x-coordinate of the vertex is minus b over 2a, so in this case it will be minus 1 over 2 times a, which is 2 times 0.1, so it's 0.2, so that's equal with negative 5. So that means that is approximately, let's say approximately here, so the vertex is approximately here. So, okay, so that's the x-coordinate of the vertex. That's the x-coordinate of the vertex. And if you see here, the discriminant of this quadratic here is b squared, which is 1 squared, which is 1 minus 4 times the 0.1 times the 40. So, which of course, this here is a negative number. So that means that this equation, this graph here, this equation doesn't have roots. So that means that this graph does not intersect the x-axis. So, and we said that the vertex is here. So that means that, it's approximately like this here. Let's do it with the red color. It's approximately like this. And of course you can go like this, but we're only interested in whatever is in the first quadrant. So, which is this? It's this part here. So now, we want to find this here, the point of equilibrium. Of course, now you have to equate both equations. So what do we have? We have this here, 0.1 x squared plus x plus 40 has to be equal with minus 0.2 x squared plus 80. So if you bring everything to the left hand side, you have, this will become 0.2 plus 0.1, and this will become 0.3 x squared plus x plus 40 minus 80, so that's minus 40 is equal to 0. So what's the square roots of this here? So the square roots of this are, if you take the formula that gives you the roots, so that should be x1, 2 is equal with minus b, which is 1, so it's minus 1 plus or minus 1 square again, which is 1, minus 4 times the a, which is 0.3, times the 40, times the negative, the negative 40, base over 2 times the 0.3, which is 0.6. And this will be minus 1 plus or minus. So how much is this here? 0.3 times, of course we have negative times negative, it's positive, so that's 4 times 40 times 0.3, so it's how much is this? 0.3 times 4. Yeah, so that should be 120, so that's 12. 12 times 4, so that's 36. This is 3 times so that's so that's 4 times, so that's 4 times 12, so that's 48. That's 48. 4 times 12 is 48, plus 1 is 49, so of course the square root of 49 is 7. Okay, that's nice, or 0.6. So the one will be one root will be negative 8 over 0.6, which of course doesn't count because we cannot have a negative number here, and the other will be minus 1 plus 7 over 0.6, which is actually 6 over 0.6, so that's actually 10. Okay, so very nice. So that means that this point here is x, doesn't look exactly, but approximately. So the x actually here is 10, and if you want to find the corresponding price, let's say p bar. So p bar, it will be, you can plug it in any of these. This x here, you can put it in any of these two equations, and will either in this or in the demand equation. So let's put it here. So how much it will be? It will be 0.1 times 100, which is 10 square, plus 10 plus 40. So how much is all this? All this is equal with all this is equal with 10 plus 10, 20 plus 40, 60. So this value here it's 60. And finally, let's find the consumer and producer surplus. So we know, first of all, from the theory that the consumer surplus is equal with the integral of the price demand equation minus the bar price with respect to dx, and that's from 0 to x, to bar x. So in our case it should be, like we said that the price demand equation was 0.2x squared plus 80. So that was the price demand equation minus the bar price, which is 60, and that has to be integrated of course with respect to dx, and has to be integrated from 0 to bar x, which is 10. So anyway, this is nothing difficult. So the integral of these, 80 minus 60 is 20. So that means that we have to find the integral of 0.2x squared, so which is 0.2x to the third over 3 plus, we said 80 minus 60, so that's 20. So the integral of 20 is 20x, and we have to integrate this from 0 to 10. So okay, so that should be 0.2 times 10 to the third is 1000 over 3 plus 20 times 10 is 200. And then of course you have to subtract it for x equal to 0. So substituting in this equation here, wherever x is equal to 0, and of course everything will become 0. So this is, how much is this approximately? So that's this is 200 over 3 plus 50, so that's approximately $86.6. So that's the consumer surplus. And finally, let's calculate the producer surplus. So the producer surplus, as we said before, it's given by the integral bar P minus the price supply equation dx, and that's from 0 again to bar x, and in our case it's 0 again to 10, and the bar P is equal with 60, and the price supply equation is 0.1 x squared plus x plus 40, and of course all of this has to be with respect to dx, and this is from 0 to 10. Now like what we have here, we have negative 0.1 x squared, negative x, and 60 minus 40 is 20, so plus 20, and that's with respect to dx. And now the integral of this here it's minus 0.1 x to the third over 3 minus x squared over 2 plus 20x. And now again, this has to be integrated from 0 to 10. So let's finish it here. So you just have to substitute whatever x stands, so that should be 0.1 times 10 to the third, so it's 1000 over 3 minus x squared over 2, so that's 100 over 2 plus 20 times 10, which is 200. So in this here is 50, this here is 100 over 3, so it's 33 point something, 33.33. So all this together is 200 minus 50, it's 150 minus 33.33, so that's equal with 33.33, so that's 116.66, so approximately $116.66. So that's the producer's surplus. So both producer and both the producers and the consumers hypothetically gain something when the product was sold for 60 for a unit price of 60. So that's it about consumer and producer surplus. I hope you find this presentation useful. See you next time. Bye for now.